Morning, everybody. Today we're looking at linear relationships, video number 8. I'm going to post another video that I found on YouTube to go with this. It's a pretty good video. So I thought I'd do my own just to show you some of my own examples. What we're studying today is this. We're going to go from this form, it's called standard form of a linear relationship, to the form we've been using, y equals mx plus b form. All right? You can represent a linear relationship like this or like this. And there's other ways too. This is called standard form. It always looks like ax plus by equals c, where a is a coefficient on the x term, b is the coefficient on the y term, and c is some constant out here. Here's an example of a linear relationship in standard form. Well, we want to convert this into this form, slope-intercept form, because this is easy to graph. That's why we're doing this. Can you take this form, make it into that, then we can graph it. This is going to be real important in our next unit. So here's an equation. We want to make it look like that. Here's a standard form equation. We're going to this form. But you just got to notice up here, I need to isolate the y, it's called. Or some people say I'm going to solve for y. Or you could just in regular way get y by itself. You look over here, you got all this other stuff over here. You got a 4x term, and you got a coefficient on the y as a 2. We need that coefficient to be a 1. So we're just going to use our algebra skills to do this. So I need to get this 4x out of here. I want to make it a 0. First, we always get rid of this term that's added in. So we're going to do minus 4x. 4x minus 4x is 0. 0 plus 2, so you get 0 plus 2y. Additive identity, 0 does nothing. We have 2y. Now, since you subtracted 4x from this side, I'm going to do subtract 4x from this side. Now, be careful here. You can't do 12 minus 4x. They're not like terms. So you could write 12 minus 4x. That is mathematically accurate, but it doesn't look quite like we have over here. I want the variable term first. So I'm going to use the commutative property. I'm going to do this the long way. Remember, you could write this as plus a negative 4x. Subtraction of 4x is the same as adding negative 4x. Now we have addition, so we can use the commutative property to switch them. You get negative 4x plus 12. Okay, so I just did a little manipulation here to make it look like that. Now over on the left side, we still have 2y. So we're close to this, but not quite there. I need this to be a 1. So an easy way to do it is divide by 2. Now, if you're going to divide this by 2, you're going to divide this by 2. Now remember, when you're dividing a binomial by 2, you got to divide every term. As a matter of fact, you could write it like this. Negative 4x divided by 2 plus 12 divided by 2. I don't usually do this. I just put divide by 2, but remember to do every term. 2 divided by 2 is 1, so I get 1y equals negative 4x divided by 2 is negative 2x plus 12 divided by 2 is 6. So I get 1y equals negative 2x plus 6. I don't even need that 1. Identity property of multiplication. You get y equals negative 2x plus 6. Now it looks like that. I can see the slope right there of negative 2, and the y-intercept is 0, 6. That's ready to graph. All right, so to recap, I had standard form. I just manipulated it to get it into slope-intercept form. Now I want to show you one other example. This was on that other video I posted. I do it a little differently than the guy on that other video. He's correct, but I don't know, I just always do it this way. So here's the standard form, ax plus or minus by equals negative 3. I want y equals mx plus b. So I got to solve this for y, basically. So I'm going to do minus 2x here. That makes a 0, it's gone. Minus 2x over here. Now be careful, don't lose this negative. 0 minus, I'll write it down. It looks like this. This is a 0. 0 minus 1/3 y is negative 1/3 y equals, over here, I had negative 3 minus 2x. Well, I'm going to switch this around using commutative property. and it's adding a negative, so I get negative 2x minus 3, or plus a negative 3, but minus 3 is easier. I want that x term to be first. Now I got to get rid of this negative 1/3 coefficient. I need to make that a 1. The easy way to do it, multiply by the reciprocal, or the multiplicative inverse is another word for it. What's the multiplicative inverse of negative 1/3? Negative 3 over 1. It's the reciprocal or multiplicative inverse. So I get negative 3 times negative 1 is 3. 1 times 3 is 3. So I get 3 over 3y, which is 1y, which is just y. So we made that coefficient into a 1. Now if I multiply this term by negative 3 over 1, I got to multiply this whole thing by negative 3 over 1. So use your distributive property. Negative 3 times negative 2x is 6x. Negative 3 times negative 3, watch your signs, it's positive 9. So we get y equals 6x plus 9. Now we have this in slope-intercept form. There's my slope. My y-intercept is 0, 9. This thing's ready to graph. Done.